Welcome to All This Math. This is Professor Parker, and today we're going to be doing a little work with Algebra 2. The reason I'm doing this video in particular is because my man Flip, Mighty Flipside Esquire, hit me up yesterday. This good brother is a teacher at Belmont Charter High School out in West Philly. I believe it's in West Philly. And he's trying to work with a young brother over there, and he needed some help with how to do this type of problem, where we're trying to find the equation of a parabola when we're given 3 points that are on that parabola. So shout out to Flip and shout out to the young brother that's going to benefit from this video mainly. And all the rest of you too that's going to be watching this video and need to know how to do this skill. All right. So one thing I want us to think about first before we even get started is, number one, what is a parabola, right? Because I don't like to just throw around terminology without being clear that everybody knows what we're talking about. A parabola is a graph that either typically looks like this or looks like that, right? That's a parabola. Now, the parabola could be sideways, right? But we're not dealing with that today, okay? So the parabolas that we're dealing with, where we have y is equal to something x squared plus something times x minus another number or something like that, they're going to look like this or that, like this or that, all right, like this or that. Either they're going to open up or they're going to open down. The way that we know if it opens up or opens down is if the a value, which we'll talk about in a minute, is positive or negative. If the a value in the equation of the parabola is positive, that means it's going to open up like this. If the a value in the equation of the parabola is negative, it's going to open down like that. Now, here's another thing I want you to think about. There are a lot of different types of graphs, a lot of different types of equations in algebra, but the way that we know that the graph is going to look like a parabola is if it's in this form. Let me write this. Y equals ax squared plus bx plus c. All right. So basically you have a variable raised to the second power. That's your biggest exponent. If it was a variable raised to the third power, it's not going to look like this. Fourth power, not going to look like this. If it's a square root, it's not going to look like this, right? So different types of equations got their own look, right? The parabola, well, this type of equation looks like this, either this or that. One of these two, all right? But now today what we have is we have 3 points. 1, -2, 2, -2, and 3, -4. So they give us these 3 points, right? And from these 3 points, we got to figure out, all right, what's the equation that these 3 points would be on? What's the equation of a parabola that these 3 points would be on? All right. Now, keep in mind, a parabola has an infinite number of points. I mean, it basically has billions and billions of points on it, right? A parabola is either going to go up forever to infinity and never stop, or it's going to go down forever to negative infinity and never stop. So this curve is made up of a whole bunch of little points, microscopic points that connect to each other, right? That's how we make a curve, just like that's how we draw a line. There's a whole bunch of microscopic little points that connect to each other. So it's an infinite number of points on here and on here. What we're saying is, I want you to find the equation of a curve, right, that either looks like this or looks like that, that happens to have these 3 points on it. That's what we're saying. All right. And now I'm going to break down for you how to do it. Okay. So let me make some space because it's going to take a lot. I'm going to just forewarn you. These problems are not light. This is not light work, right? These problems are serious and they take a lot of work, right? And a lot of steps. But if you understand the steps that I'm going to break down for you and use these steps every single time with every single problem, you'll be good. What you need to know how to do is solve a system of equations, which is when it's in 3x3 format, right? 3 variables, 3 equations. That's called 3x3. That's a 3x3 system of equations. You also need to solve a 2x2 system of equations, which has 2 variables and 2 equations in it. All right. Now we take the 3x3 system and we break that down into a 2x2 system, and that's how we figure out the missing variables that we're going to need in order to put our equation in this form. This is our end goal. Our end goal is to figure out an equation that looks like this. It's got to look like this. All right. Now, The thing we're going to have to figure out in order to do that is what is our value of A, what is our value of B, and what is our value of C? Because we don't know this. We're given 3 points. So we know the value of Y and X, right, in 3 different ways, right? But we don't know the value of A, B, and C. And that's where solving a system of equations comes into play. All right, so this is what we're going to do first. We start with our first point. In our first point, the first number is X, the second number is Y. First number is X, second number is Y. Let me just label these right now. First off, I'm only going to use the first point. So then I'm going to use this equation. I'm going to take this equation and I'm going to replace the Y and the X's with these 2 numbers, right? That's your first step, all right? That's your first step. Go to the first point and say, okay, X is 1, Y is -2, right? Then I go to this equation and I say, all right, bet. I'm going to replace the Y with a -2, right? The equal sign. The A, we don't know. We leave the A there. Replace the X with a 1. Put your exponent like that. Use parentheses to separate everything. Keep everything nice and neat. Then I got plus, write the B down. X again is still 1. And this is just a C, right? So now, this is how we set this up. This is how I take this point and incorporate it into the general form of the equation, right? Then I need to simplify this. So I'm going to say, okay, -2 is equal to, now, order of operations. You got to use order of operations. What's 1 squared? 1 squared is 1 times 1. 1 times 1 is 1. 1 times A is just A. Over here, B times 1 is just B. And then I got plus C. So that's one of the equations that I'm going to use for my 3x3 system. That's one of the equations I'm going to use for my 3x3 system. 1 down, 2 more to go. Now, I'm going to repeat the process. I'm just going to repeat the process, but now I'm using point number 2. Check this out. Matter of fact, let me try to color code. Let me use a different color. Try to, flip it around. All right. Now, my Y value in this, for this point, is still -2. So I got -2 equals A times +2, because that's a +2 right there, squared, plus B times +2 plus C. Now I'm going to simplify that, right? So now I got -2 equals 2 squared is 4. 2 squared is 2 times 2. That's 4, right? So I got 4A. And then B times 2 is 2B. And then plus, and then C. So that's my second equation for my 3x3 system. In my 3x3 system, I need 3 equations. I got one joint right here. I got another joint right here. And now I need to figure out my third one. So let me do this. Let me switch the color up again. Let me get to the green. All right. So now I use the third point. I'm going to repeat the process, except now I'm using the third point. So my Y is -4, and I'm following this equation. This equation, I replace the Y with a -4, which equals A times +3 squared plus B times +3 plus C. Now I'm going to simplify this. I got -4 equals 3 squared is not 6. A lot of people make that mistake. That's a rookie mistake. Don't do that. 3 squared is 3 times 3, not 3 times 2. A lot of people get it confused because they say, oh, but 2 squared is 4, and that's 2 times 2. Well, that's because you're multiplying 2 by itself one more time. That's just a coincidence. You're multiplying this number by itself. So 3 times 3 is not 6. 3 times 3 is 9. Remember that. Remember that. So we got 9A plus B times 3 is better written as 3B plus C. Now I'm in business. Now I got my 3 equations that I need for my 3x3 system. And I told you this problem is long. We're not done yet. We might be almost halfway done. We got our 3 equations for our 3x3 system. So what I'm going to do is I'm going to write these 3 equations together in the form of a system. And I'm going to also switch it around because I don't like having the constant on the left side. I like having the constant on the right side because I like to read from left to right. That's That's just my twist. I just like to have the constant on the right side. So this is going to become A plus B plus C equals -2. That's my first equation. And this one is going to be 4A plus 2B plus C equals -2 also, right? 4A plus 2B plus C is equal to -2. And then I'm going to have 9A plus 3B plus C equals -4, right? So this is my 3x3 system, right? Now from that, what I got to do is I got to break this down into a 2x2 system, all right? Now, how do I do that? I got to pick a variable that I can cancel out using the elimination method. So go back to your notes from Algebra 1 with solving systems of equations where you use the elimination method. Some textbooks call it the addition method because really what you're doing is you're adding one equation to another, right? In order to get one of the variables to cancel out, because you got to get rid of one of the variables. That's the name of the game. Get rid of one of the variables. That's why many textbooks refer to it as elimination method. And my old heads, when they taught me, they referred to it as the elimination method. And that's how I remember how to do it and what I'm supposed to do, right? So what I'm going to first do is I'm going to group these two equations together. But then I'm going to change this to a -c. Because what's -c plus c? 0. They cancel out. But how do I do that? I got to multiply this by -1. This whole equation has to be multiplied by -1. So watch this. I'm going to have A plus B plus C equals -2. I multiply that by -1. Right? When I multiply that by -1, it's going to become this. -A plus B plus C. I'm tripping. Hold up. It's not. It's -A minus B. Yeah, see? -1 times A is -A. -1 times B is -B. -1 times C is -C. -1 times -2 is +2. So that's my new first equation. Now, I'm just going to rewrite the second equation. I don't need to change nothing in that one. 4A plus 2B plus C equals -2. Now, I add them together. You add them together. That's how you do the elimination method. You add them together. So I add the A's together. -A plus 4A is 3A. -B plus 2B is B. -C plus C cancels out. They add up to 0. That's what we wanted to have happen. Because watch this. And now I got 2 minus 2. That's 0. Now I got an equation with only 2 variables. That's what I want. I need an equation with just 2 variables. So I got 3A plus B equals 0. All right. Now I'm going to do the same thing with that first equation, and I'm going to match it up with the third equation. See, at first I matched up the first equation with the second. Now I'm going to match up the first equation with the third equation so I could cancel out the C's again. I need to cancel out the C's again in order to create my 2x2 system. See, I got my 3x3 system, but I got to break that down into a 2x2 system. So I got this first equation, which I already changed around into so I could get my -C. So I'm going to use this joint again. Right? So I got -A minus B minus C equals 2. But I'm going to match it up with the third equation. 9A plus 3B plus C equals -4. And now I add them together. -A plus 9A is 8A. -B plus 3B is 2B. The C's cancel out again because -C plus C is 0. It's like saying -5 plus 5. We know that that's 0 too, right? And then I got equals 2 minus 4. 2 minus 4 is -2. All right? That's my second equation. Now I got my 2x2 system. Now I'm going to put this equation with this equation, and I'm going to solve for A and B, right? So watch this. So now I got, let me switch the color up again, because now I got my 2x2 system. So now I'm going to do 3A plus B is equal to 0. That's my first equation. That came from right here. Now, where'd that come from? That came from right here. When I put the first equation with the second equation, and I canceled the C's out. That's where I got that from. Then I'm going to do this equation because it's my other two variable equation. 8a plus 2b equals negative 2. All right. Now, what I'm going to do is I want the b's and I'm going to get, I got to figure out something I can cancel out. I'm going to cancel out these b's. But I first got to multiply this by negative 2. Now, why am I multiplying this equation by negative 2? This is why. Because if I do that, that's going to change this b into a negative 2b. And how does that help me? That helps me because now when I add these equations together, just like I did over here, it's going to cause the b's to cancel out because negative 2b plus 2b equals 0. And that's what I want. I need something to get eliminated. That's why textbooks call this the elimination method. I'm eliminating one of the variables. All right. So now I got, let's see, 3 times negative 2, negative 6a. B times negative 2, negative 2b. 0 times negative 2, still 0. 0 times anything is 0. Don't ever forget that. The bottom equation stays the same. I got 8a plus 2b equals negative 2. And I know it's a lot of work. It's a lot of steps. But it's the same steps over and over again. If you learn the steps and learn the process, you can do these problems. It's not difficult. It's tedious. There's a difference between difficulty and tediousness. All right. This is tedious. Ain't no doubt about it. This is tedious. All right. So negative 6a plus 8a is 2a. The negative 2b plus 2b, 0. 0 plus negative 2 or 0 minus 2, however you want to look at it, is negative 2. Now, how do I solve for a now? 2a equals negative 2. Divide by 2 on the left, divide by 2 on the right. So we got a equals negative 1. I got one of my 3 variables. I know what the a is now. Now I need to know what the b is and the c is. I know the a, now I need to know what the b and the c is. All right, so how am I going to figure out what b is? We're going to go back and pick one of these equations. Matter of fact, I'm going to pick this first equation. I got choices. I could pick the first equation or the second one. It don't matter. Whatever you want to do. Sometimes you might want to pick the bottom equation. Sometimes you want to pick the top equation. It don't make a difference. So what I'm going to do is, and I'm going to use the form that it originally was, like it was over here, before I multiply by the negative 2, because that just makes things more simple. So watch this. I'm going to bring this over. So now I got 3 times negative 1. I'm not using a. I don't need to use a because I know what a is. The purpose of variables is to represent a number that you don't know. Now we know the number, so we don't have to use the a anymore. Now we know the number. So it's 3 times negative 1 plus b equals 0. Now I'm trying to figure out what b is. First I simplify. 3 times negative 1 is negative 3 plus b equals 0. How do I solve for b? I got to get rid of this negative 3. The opposite, I got to do the opposite operation. The opposite of a negative 3 is a positive 3. So that means I got to add 3 on the left side and add 3 on the right side. B equals positive 3. Now I got my second value. I know my A and I know my B. I know my A and I know my B. Now I just got to go back and figure out what C is. Now, check this out. I can't use these 2 equations to figure out C because these 2 equations don't have C in it. But what equations do have C? All 3 of these joints. I could pick any one of those. It don't even matter. I could pick any one. I think it's easiest to pick the first one because the first one has the smallest coefficient. So you got 1a plus 1b plus 1c equals negative 2. I'm going to just use that. So watch this. I'm going to have, let me see. Okay, a is negative 1. I'm going to use this first equation. Right? And I'm a little pressed for space, so watch me do this. I'm going to do this diagonal, right? First equation, I replace a with negative 1. Write a plus sign. I replace b with positive 3. Write another plus sign. I don't know what c is, so I write plus c. I still got to use c because I don't know what number it is. Not yet. I'm about to find out. That's equal to negative 2. Now, I simplify by combining like terms. What's negative 1 plus 3? Negative 1 plus 3 is positive 2. So I got 2 plus c equals negative 2. Now I want to solve for c. So I got to isolate c by itself by getting rid of this 2. What's the opposite of a positive 2? a negative 2 or subtracting 2. So I got to subtract 2 on the left and subtract 2 on the right. Everything's got to be balanced. So now I got C equals negative 4. And now we're about to be done. Finally, after all this work, we're about to be done. And every problem like this is done the same way. Every problem like this is done the same way. You start out with your general form of a quadratic equation, right? You take each point, plug it into the general form of the quadratic equation to create an equation with your A, B, and C variables. You do that 3 times. You do it once for each point. You create your system of equations, your 3x3 system, and then from your 3x3 system, you break it down like I did over here, right, to create your 2x2 system. Once you create your 2x2 system, you can solve for 2 of the variables. Once you solve for 2 of the variables, you go back and you solve for the 3rd variable. And now we write our answer. Our answer is, we're basically rewriting this, except we're replacing the A with a negative 1, replacing the B with a positive 3, and replacing the C with a negative 4. So check this out. We got y equals negative x squared. The negative sign represents negative 1 when it's a coefficient. You don't have to write negative 1. You can just write the negative sign. B is 3, so that's plus 3x. And then we have plus negative 4, which is the same thing as saying minus 4. And this is your final answer. So this is the equation that represents the parabola that includes these 3 points. This is it right here. Right? So now if you plug these points in to this equation, then the left side will equal the right side. The y value will equal the value that's over here from plugging in the x values. Squaring them, multiplying by negative 1, adding 3 times that same x value, and subtracting 4. All right, so this is like the name, like the parabolas that I drew. The parabola is like a picture, right? But this equation right here, this is the name. Just like we all have a name and we have a physical look. Our physical features, that's like the parabola, right? And also, see this A value is negative. So if I was to draw this parabola, it would open down. It would open down because this A value is negative. Whenever the A value is negative, the parabola is going to open down. All right? All right, well, I hope that was helpful. This video was long. It's probably the longest video I've done in a minute, like 22 minutes. But this is advanced algebra. This advanced algebra. And again, like I said, it's not really difficult. It's tedious. I will admit that it's tedious. But when you're dealing with things that are tedious, you just got to buckle down, become very detail oriented, and just follow the steps, step by step. And before you know, you're going to be done. So what you should do is take this example and then find some other examples and just do them. Just do all the examples. That's the only way you learn it. Through repetition. That's it. All right. So hope that was helpful. Please like the video, subscribe to the page if you haven't already, share the video, go into the page and share some other videos. You know, I got a lot of content up and I'm putting up content on a regular basis. All right. Peace.